I love torque wrenches. They're an amazing tool and they help you get the job done, especially when critical torques are required. You just put a socket on a torque wrench, you put it on a fastener, and you torque it. But what if that fastener requires a critical torque and that fastener is hard to get to? That, my friend, is what separates rookies from professional, and that is what this video is about. Today I'm going to teach you how to properly use a torque wrench and get the job done right, even when fasteners are hard to get to. Let's dive right in. First, we're going to talk about some basic information on how to use a torque wrench, and then we will dive into the advanced applications of this amazing tool. Let me show you. So first of all, what is a torque? A torque is a torsional value that is a result of a force times the length of a lever. Let me show you. Say we want to obtain 40 foot-pounds, or the proper nomenclature would be 40 pound-feet of torque, but being that it's a multiplication, foot-pounds or pound-feet is the same thing. In order to obtain 40 foot-pounds of torque, you can either apply 40 pounds times 1 foot of lever, right? Or you can do 20 pounds times 2 feet of lever. That is also equal to 40 foot-pounds. Sorry guys, I'm left-handed, so it tends to cover the numbers. You can also do 10 pounds times 4 feet of lever. You would still get 40 foot-pounds, and so on. You can do 8 pounds times 5 feet, or you can do 5 feet times 8 pounds. You can do literally 4 pounds times 10 feet. You can even do 2 pounds times 20 feet, or even 1 pound times 40 feet. All these combinations, you will obtain 40 foot-pounds of torque. Nowadays, we have these very modern torque wrenches. I don't know if you can see here. Let me zoom out for you. See this right here? This is a 3/8 drive torque wrench, and they come in different drives. You can get a 3/8 drive. You can get a 1/4-inch drive, or you can even get a 1/2-inch drive, and they come even bigger than this. But these are your basic setups. And these torque wrenches, if you'll notice, they come at different lengths. For example, and you always measure from the center of the handle. This one here, 1/4-inch drive, is a 9-inch torque wrench. The 3/8 drive is say a 13-inch torque wrench, and your 1/2-inch drive is a 16-inch torque wrench. Whenever you're working on a car or an airplane or a boat and you're dealing with fasteners, meaning nuts or bolts, they're always going to require a torque. Now, oftentimes the procedures come with torque specifications, and you could get those procedures usually with the automobile or the airplane or the boat that you have. For example, this is a typical owner's manual or maintenance manual for a Toyota Solara Camry, and in it you will find procedures for different things. There will be times when the procedure will tell you to remove and install and replace something, but it doesn't give you a torque spec. But these books do come with standard torques, such as these ones here, and it gives you different dimensions of the shank of the bolt with different thread counts, and what the torques is for either foot-pounds or inch-pounds or Newton meters, because being that we have American, European cars, different companies use different system of measurements to identify their torque specifications. One thing to keep in mind when you're dealing with torque wrenches, these are a precision tool and do require calibration if you aim to get the job done right each and every time. What you want to do is either send that out to a calibration lab, or if you have the means to calibrate it yourself, do so. But if you're going to send that out to a calibration lab, be sure to have the torque wrench calibrated counterclockwise and clockwise, and we'll get into the details of that. Also, a torque wrench is for torquing fastener. Just because it has a ratcheting feature, that doesn't mean you are to use it as a ratchet. That's what you use ratchets or breaker bars for. A torque wrench is for torquing fasteners only. In the world of torquing fasteners, there are other components that will aid you in getting the job done right. In a simple application, you just put a socket on a torque wrench. You adjust the torque on the actual torque wrench according to the specification needed, such as, for example, if you wanted if you needed 40 foot-pounds, you rotate this until the 0 aligns with the number 40, like so. I don't know if you can see it. Can you see it? And if you needed less than 40 foot-pounds, this would be 44.5, whereas this would be 40.5 foot-pounds. So this torque wrench has increments of half a pound of force. Again, when you're done with the job, you always want to make sure that the torque wrench, it's back to its lowest setting. I personally like to do it lowest setting minus 1 click to take all the tension off the mechanical system that lies inside of the torque wrench. But there are other things you can use that help you get the job done right. One of them, it's these ones here. These are called torque adapters. You can get them as standard or metric. This is, for example, is a standard set. And this one here in particular goes from a 3/8 with a 3/8 drive all the way up to 7/8 with a 3/8 drive. And you'll notice that they're all 2 inches in length. Now, besides the standard sets of a 2-inch size adapters, there's other adapters you can use, such as this one here. This one here is an adjustable adapter. That's what I like to call it anyway. It's by Motion Pro, and that's the part number right there, 08-0380. The beauty of this torque adapter, say a 2-inch setup does not work for you, right? And you can't quite get the job done. So what you can do is, say you have a 18mm fastener. What you do, you set it inside this adapter. Mind you, this adapter is a 3/8 drive, as you can see. But keep in mind that when you do set the wrench inside of this this adjustable adapter, use this scale to see what kind of measurement, what kind of length, what length is the. Let's say you're going to use the rounded edge from the middle. So let's say your fastener is going to be the adapter is going to be 4 inches from the center, right? Like so. This is about 4 inches right here. And I'll explain to you why this is important. Because the moment you start using adapters, you'll have to use a formula in order to get the proper torque, called a settled torque, on a torque wrench. For example, say you have to, let's use this one here for example. Remember how I told you that a torque can be, if you want to apply 40 foot-pounds, it can be 40 pounds on a foot, or it can be 4 pounds and 10 feet. The same concept applies when you use a torque adapter. If I put this torque adapter here at the end of the torque wrench like so, I have effectively increased the length of the torque wrench. And so if I set this to, say, 40 foot-pounds, we're just going to keep playing with this number because I like 40. Maybe I just wish I was 40 again. I don't know. if we use an adapter of 2 inches and we set this torque wrench at 40, when we apply the torque, there will be more than 40 pounds applied on this fastener. So the way to properly calculate what the settled torque is, this is the formula right here. Settled torque, let me see if you can see it. Settled torque equals required torque times the length of the torque wrench divided by the length of the torque wrench plus the adapter. So say we don't know what the settled torque is, right? We're going to call that X. The required torque is 40 foot-pounds, right? Times the length of the torque wrench. Now, what did we say this torque wrench was? This 3/8 drive here is 13 inches. Let me show you. Because you measure from the center of the handle. This is a 13-inch. It goes from the center of where the torque is applied to the center of the handle, 13 inches. So we write that here, times 13 inches of the torque wrench, divided by the length of the torque wrench, again, 13, plus the adapter. And what is the length of the adapter? What did we say it was? It was 2 inches, right? These adapters are 2 inches from center to center. Plus 2. So this would equal 2. 40 times 13. What is it? 520? 40 times 13 equals 40 times 13 equals 520 divided by 15. That equals, divided by 15 equals 34.66 foot-pounds. So, if you were using a 13-inch 3/8 drive torque wrench with a 2-inch adapter on the end, and the torque required was 40 foot-pounds, the settled torque would be 34.66. So you adjust this dial here to 34.66. And being that this is a half a pound increments, I would go to 35. I would go to 34.5. Or you could go to 35, whichever is you're more comfortable with. It all depends on the type of metal and the actual application. Some torque applications or torque specs give you a range, where this is not, this is just to give you an idea of what we're doing here. Now, I always advise that if you are using one of these torque adapters, if at all possible, so that you don't have to do any calculations, put the adapter, if the job allows it, if you have the space to do it, put the torque adapter at 90 degrees. Why? Because you have effectively eliminated the need for the formula, because from here to the middle of the handle is 13 inches. I've talked about this actually on a couple of jobs that I did when I was doing the shocks on the Mercedes ML500, where you saw me on the front shock using a crowfoot like this one here, and I had to torque the top nut of the strut. Being that I needed an 8mm to hold the top of the strut so that the shock itself inside would not rotate, I had to hold the top of this strut, and with the torque wrench, crowfoot at 90 degrees, I applied the torque. Same thing happened when I had to when I had to torque the rear, when I did the rear shocks on the very same car, the Mercedes ML500, when I did the lower wishbones, and I had to apply the torque. I had to use a similar setup, but instead of using an adapter like so, I used an adapter like this one, where I ended up using whatever the size was, and I placed it at 90 degrees like so that I wouldn't have to deal with having to calculate length. So when I just did like this, and I applied the torque. If you're using a crowfoot, the same concept applies. This is another aid in torquing fasteners right here. For example, the center of the drive to the center of the, let's say what is this? This is a size, this is a 7/8. From the center of the 3/8 drive to the center of where the nut goes is about 1 inch. So the same thing same thing applies. So if you're gonna end up using this formula here, if you end up using a torque wrench like so, right? And what you do, if you're doing a 40 foot-pound for the sake of conversation, this number here, the letter A, would be 1 instead of 2. Now, in the world of torquing fasteners, if you use an extension, it is totally acceptable so long as it's good quality steel and it does not flex on you when you apply the torque. Because you see, it doesn't change the length of the arm, but it does facilitate applying the torque. Now, one little caveat when you use extension in hard to get places, if you end up having to torque a fastener in like fashion where the adapter is in the back end of the torque wrench, instead of this being a plus, it will be a minus. And the reason for the minus instead of the plus is because we are effectively reducing the length of the arm or the length of the lever on which torque is being applied. Say again, we had to apply a torque of 40 foot-pounds. We don't know what the settled torque is, right? So we're going to call it X. Required torque is 40 foot-pounds times the length of the torque wrench. Being that we're still with the 3/8 drive, we know that it's 13 inches long, right? Divided by the length of the torque wrench, which is 13. But in this case, instead of adding plus 2, which is the length of the adapter, we're going to do minus 2. So in this case, what would be the settled torque? 40 times 13 is 520. 13 minus 2 is 11. So the settled torque would be, clear, 520 divided by 11 equals, you would have to set the torque wrench to 47.27 foot-pounds to get a 40 foot-pound required torque. That's what the settled torque will be, 47.27. Other tools that you can use as to help with the adapters when you want to get a torque done are these, I call them reducers and enhancers. This goes from a 3/8 drive to a 1/2 inch drive. This one goes from a 3/8 to a 1/4 drive. This one from a 1/4 to a 3/8 drive, and this one from a 1/2 inch to a 3/8 drive. I use this a lot, especially when I use say a 1/4 inch drive ratchet. As a matter of fact, I just did this job the other day when I had to torque the terminals of a starter generator on a Honeywell auxiliary power unit. And what I had to do, I had to apply a really big socket. I think it was what was it, a 13/16 or a 7/8, but the torque was only 190 inch-pounds. So what I did, being that the socket that big, it has a 3/8 drive, I ended up applying the socket in the end right here, and then setting the torque wrench to the desired torque. So yes, these are also very useful in a world of torquing fasteners and getting the job done right. There is one last scenario where a different formula would be required to calculate what the settled torque is, and that would be in case you had to use a specific angle for the application of a torque. Say, for example, you're using a torque adapter, right? Whether it be by itself. Yeah, we're going to use it. I don't know. We're going to use this one here, right? Say you had to use a torque adapter, but for whatever reason, you could not use the adapter in this fashion, meaning straight, nor could you use the torque adapter at 90 degrees, but rather it required that you use the torque at either, let's say, 45 degrees. Yeah, I did a sketch back here to give you an idea. It either had to be at 60 degrees, right? More or less. Or the torque had to be at 45 degrees, or the torque had to be done at 30 degrees, right? There's a formula that helps you calculate what the required torque or the settled torque is to get the job done right. Let me show you. Now, this very setup with an angle is also true if you had to use an extension, right? And to say that not only are you not applying the torque like this, but you're applying it in such a way where the torque applied is actually upside down, and you are actually twisting the torque wrench counterclockwise. This is why I said to you in the beginning of it and at the beginning of the video to make sure that when the lab torques your equipment, it's not only getting torqued clockwise, but it's getting torqued counterclockwise. So if you were to torque at an angle upside down and the torque wrench is going counterclockwise, if you needed an angle to get the job done right, this is the formula right here, guys. Let me show you how it works. And I will also give you the numbers of the cosine of the angle D. There's standard numbers for 10 degrees, 20 degrees, 30, 45, 50, 60, and 90 obviously is 0, because what did I say to you? When you apply a torque with an adapter, even if you have an extension and that adapter is at 90 degrees, no formula is needed. But back to the angle. Again, we're going to do a 40 foot-pounds as your required torque. So we don't know what the settled torque is. So we're going to call that X. Required torque is 40 foot-pounds times, again, the length of the torque wrench in question, being that we're using a 3/8 drive, is 13 inches, divided by, parentheses, 13 inches plus adapter, whether it be your standard 2-inch adapters or whether it be something that you're using that it's custom length and you would have to decide what that length is. Say, but because we're using the 2-inch adapters, we're going to say 2 times the cosine of, say the application is done at 45 degrees. So what is the cosine of the angle at 45 degrees? Let me show you. These right here and are some of the angles, and I'll give them to you on the video as well, but I'll show them to you again. For 10 degrees, it's 0.98, for 8, 20, 30, 40. Being that we're using 45 degrees, is 0.70711, right? So that's the number that we're going to need. We're going to put that aside. We're going to set our torque wrench, right, at 45 degrees. What did I say that angle was? Just so that I can give you a visual of what I'm talking about. This is about 45 degrees right here, right? So at 45, we're going to apply this torque at 45 degrees, and we said that the cosine of the angle D at 45 is 0.70711. So order of operation, we do the math inside the parentheses first. So 2 times 0.70711 equals 1.41422. We know that 40 times 13 is 520. 2 times the 13 plus, this would be 1.41422. So again, 520 divided by 14.414 30.41422. So what is that? 520 divided by 14.41422 equals 30.07. 30.07. So what does this mean? That means if you wanted to get a nut or bolt torqued at 40 foot-pounds, and you had a situation where you were using a 45-degree angle with a 2-inch adapter, the settled torque would be 30.07 foot-pounds is what you would be applying the torque wrench to. Now, there is one less caveat when it comes to applying torque to fasteners. The rule of thumb is that whenever you apply torque to any nut and bolt application, the nut by default is what receives the torque, not the bolt. Unless the bolt is going into a fixture, then the torque will be applied to the bolt. But if it's a torque applied to a nut bolt application, by default, it is always the nut that gets the torque, never the bolt, because the bolt, when it's inside of a tube or some kind of structure, it creates a drag torque, and that would not provide an accurate torque when you're torquing the bolt to the specified torque. And that is all, guys, on how to use a torque wrench and its adapters on more advanced applications. I hope, as always, this video was of help to you. If you have any questions or comments, or something is not clear to you, be sure to leave a comment or a question in the comment section below, and we will see you at the next one. Take care.